Well, here's my motor back. Turns out that the stationary switch had a cold solder joint, and one of the winding junctions had a cold solder joint. So it was like Monday morning or Friday afternoon or something. The guy, or maybe it was a guy learning how to solder. So I didn't have to rewind it. It's fantastic. So now it's set for 220. Only had one problem. The guy knows motors, but given that there are marks right here from the puller he used to take the pulley off. See there? What's wrong with this picture? Yeah, pulley's on backwards. So I gotta pull it off, flip it over, put it back on, which is kind of cool because then I'll be able to make sure that I have it aligned properly. But yeah, it will work that way, but all of my speeds will be completely wrong. Like the high speed will be frigging crazy fast. I don't really want to do that. So stand by. My favorite words. I gotta fix it. You always gotta fix the thing you just had fixed, right? But other than that, the fella that did this motor is my hero. So stay tuned. Hey guys, Kim here. Back in the shop. I got my motor back, and so I'm putting the lathe back together. And the motor is, well, I haven't run it, but I trust the guy. He wouldn't give it back if it didn't work. He also found a couple of cold solder joints in there. So yeah, it's a really good guy on motors, but let me show you this bit. Bring it over. I think I already got this. See the scratches right there? These scratches over here, or marks, are caused by the puller you use to pull this gear off, right? And I got the motor, it was like this. Upside down. More importantly, right around this opening, somebody beat on it with a hammer. And yeah, I don't have a problem with using hammers, use them all the time, but what they did was roll this edge down and create a burr in here, like a thinner area. So you can't even get it close to starting down that shaft with this deformed metal. So I'm gonna have to go after it with a file and work this thing back to roundness. Should be fun. If I had a lathe, I would just chuck it up and go in there and turn it off of there. And actually I do have a lathe. I got the little one outside I could use. It's got a pretty good friggin' lip. Annoying, but it's all good because I'm a machinist. No, I'm not. I'm a hobby machinist. That's what it is. I am a master technician, a master welder, and a master fabricator, but I am just, you know, I've only been messing with machine tools as a machinist for about 6 years. So I'm still got a lot to learn. So stand by again. We'll see what goes on. Alrighty, we're gonna yank her off of there. Let's see. Yeah. Oh, that works nice. It's always good to have the proper tool. As long as I got enough bolt. I'm about to run out. Huh. Let's see. About halfway. Yes, sir. Guess I gotta drop a spacer in there. Oh, we got anything else? That ain't too good. Let's see. How about this guy? Oh, that might work. Stick a nut in there. You ever heard that story about getting your nuts in a vise? There you go. You get to see somebody getting their nuts in a vise. It's kind of cockeyed, but I'm close to the end. Comes. Of course. It's always good to drop your wrench on your toe. Oh, any more room? Sheesh. Sheesh. How about another nut? There's one. Oh, there you go. Got a cockeyed. There you go. Only need another fraction of an inch. But you don't want to pound on a pulley, right? Oh, there she goes. Sweet. A big old burr in there. What the hell? There it is. Sweet. Bear with me, guys, while I try and get a video of this. Let's see. I gotta hold it by hand. So this pulley, I turned it around and put it back where he had it, as far as the depth and everything. Just on the outside chance that he put it back exactly the same position on the shaft as it was, only just upside down. But when I put this here, you can see that it is about, I'm gonna say 3/16 maybe, too far that way. I noticed it because when these bolts were loose, it was hanging out this way a bit. Typically a heavy weight on a belt will hang straight down, but the best way to know is to see the parallelism. See, this guy's coming out. Yeah, the outer faces of these two pulleys have to be parallel. So all I got to do is put a puller on there and yank it out. Stand by. So okay now, what I got to do is get this pulley on here, this puller. Now, it is actually rather wide on this side. I can't even get the frame bolts in it. Stand by. We gotta figure something else out. Yeah, Bozo just visited me right now and made sure I didn't turn the camera on when I started. Okay. So I got this guy on there. Where's the other half? Over here. Yeah. It's well known amongst guys that work on stuff that requires gear pullers. And you can usually hold it right there to figure out where center is, right? Then you put a little bit of tension on it and it'll hang right there. Okay. I gotta get my friggin' scale out of here. That's funny. Wait. Oh, yeah, this thing's hanging down now. It makes it look like it's where it's supposed to be. I need to tighten these bolts. Dumbass. If you want to set a critical dimension, you got to make sure everything is in the at least snug and stable in the whatever reference plane it has to be aligned with. So I got the motor in there with one bolt up on the top, so it's kind of hanging in there and staying square. I've tightened the motor mount. So I put my scale in there and see I'm dealing with about 3/16. So I got to pull it out. Alrighty. So how's that look? Oh man, that was about one turn, about half a turn actually. Tear more. You got to consider that the threads on this puller, there it is. I think I'm going to give it just one little bit more because everything will be tight and it'll be. There it is. Close enough for government work. Nice. So then just take this stuff off. If you don't have a puller like that, you should go get one. This one is a cheap Harbor Freight kind of thing, I think. But that's interesting. What is that doing in there? Anyway, that's it. That's how you set the thing. Let me get the belt on it and see what it looks like. So I have never put this lathe on high speed, you know. Oh, it's beautiful. Alrighty, next step, wire it all up. Okay, boys and girls. First thing I want to say is, if you're going to work on the wiring of anything that has electricity in it, and you find yourself asking yourself if you know what you're doing, or even less than that, like, is what I'm about to do going to work? If you're asking yourself that question, it means you need to re-examine it and try and learn everything you can about it. So the short thing is, don't watch my video and stick your hands in a box full of wires just because I did it. Do it because you know what you're doing. This is big deal stuff because I've converted this lathe to 220 volts. So what I have to do is, I did a jumper on the motor, which is easy. I had to put it back on anyway. Now I have to change the transformer that controls the contactors. If I leave it hooked up as a 12 volt system, when I turn on 220, it will burn out very expensive parts. So what I got to do is change it to 24, the 110 circuit to a 220 circuit. And you can see right here, let me, the wire's in the way. I'm gonna move this wire. Okay, now. Trying to go down into a box. There it is. Try not to make the camera autofocus. Here it says input, right? And if you look to the right of input, it says 12-11. See, move this a little bit more. Input 12-11 equals basically 110 volts. 12-10 makes it 220 volts. So what it's saying there is that if you want the input voltage to be 110, there's a jumper, and if you look up here, 12, you access this from the back of the panel. There's two wires, and they're hooked right to these two right now, 12 and 11. So it's going to make this transformer accept 220 volts and put out 21 to 24 volts. To do that, I have to change it from the 12 pin right here to the 10 pin instead of 12 to 11. So I have to unscrew this, the little screw in that hole, take the wire out, move it over, and put it in this one. That's the task I'm doing next. So understand what you're looking at. You know, it's got names and everything, but the input voltage can be changed from 110 to 220, and it still gives out 24 volts. So I don't want to burn out the transformer that makes the 24 volts. Hey guys, so one side effect of having the lathe broke down, waiting for a motor to come back, is that it enabled me to do some maintenance on it. So I did oil change, and I've been mounting the linear scales so I can put a 2-axis DRO on it, and setting up the flood coolant system, the pump and the hoses. Part of that is adding something that I wanted to do, which is to add a track for the cable management and the hose management. So let me reverse this and get a look at what I'm telling you about. Hold on. So I've got all this made, and now I'm gonna tie these two cables up to this piece of track, which involves a whole lot of sewing with cable ties. They always come with a Ziploc bag. I take them out and get rid of the bag anyway. So I'm not going to video all this, but essentially, let's see. So this is as close as it goes. Looks like I can go a little closer. All right. So this is the y-axis, and this is the x-axis, right, back and forth. So this has got a loop up underneath here. This is going to move with it, and this shield, the other side of the shield is below it. Let me back out of here. See, this is a guard, basically. So I need to just put enough slack certain amount of slack so that these two leads are not pulling too hard, and then do it to a tie wrap up here. And what I'll do is I'll go up through there, hold this guy out like this, right? Then I'll go, see if you can see that, I'll go back through. Right? So now I don't know if you can see that. The tie wrap is only on the bottom, not on the outside. And I like to get long ones because it's easier to cut them off than to find a shorter one, you know. So I hold this guy like this, give it about 1 inch of tension upwards. And you know, you can buy tools to do this, to tension a tie wrap, but fingers seem to work. I want to keep these guys laying flat. There it is. Okay, so what's going to happen, this time I went through there, and the tie wrap is kind of like this. Like this. If I do the next one like this, and so on and so forth, it'll tend to straighten out that wire. But, you know, that's the whole process. If you ever do this, pull some tension on it, tie it, you know, pick X number. It looks to me like I'm on this segment, If I go to 4 segments, it seems like it'll be pretty good. And then we'll loosen up and get used to it once you use them. And I'm not going to video all of this. So there's pretty much, get this rag out of the way. This is the back of the lathe. You can see it's close to the wall. That's about 10 inches between the, there's my hand, a little less. Anyway, this is the cover on the scale, and this is the track, and this is a piece of high quality silicone heater hose or coolant hose, heating hose, for stuff like this, for various cooling liquids that can go through a hose. So I'm going to route it all across the base of this. So basically tie wrap. I'll start by tie wrapping it right here, and then just same as this, go all the way down to the end. I also have a cable to get up into here for the light, so I got to find that too. But yeah, that's what I've been up to. I'll show more as it gets further along. Well, here you go. Ooh. I'm not going to show it moving. Well, maybe I can try it. It's running out of water now. I dumped it. It works fantastic. Okay, so there's the setup. So as you can see, it comes, this is the outlet. It comes out down here and loops down around this hose back here. You get the air hose out of the way. Got an air hose the same color. So anyway, it comes out of the back, loops up, around, and that follows the cable track all the way up to here where the thing is. And it works real nice. I need to lower the bottom guide. It's too high right now. And the dreaded handheld bit. Can you see it? I don't know. Yeah, goes up through there. Okay. This is a transfer punch. And what I did is I laid this guy down. Got it all lined up on the table, and I used a transfer punch to go through with the hammer and tap each of the holes with the transfer punch. And so they're kind of hard to see, but they're very distinctive. So I went down and put like Sharpie marks right by each hole so I can find them. I put a piece of wood under here. And see, here's the little guy. Here's a sample of the bolt that's got to go through the hole. So basically you just line this guy up and then try not to hit your fingers. Oh, wait a minute, see, I got it backwards. As soon as you go to look at the back, you'll see one side is sharp and one isn't. See? So then there's a hole right there. Perfect. Now I got to do the rest. Well, guys, here's the lathe. You know, I really like this lathe, but it really tests me. I got it all done, and the first thing that happened is the pump for the coolant stopped running, and I can get it to start, but it gets real hot. So it just never ends. Any event, I showed the video of me poking holes in this gray plastic that I used. Let me see if I can do this without being bad. That's handheld, sorry. So the thing is, a lot of stuff happened, and I lost some video, and I forgot to get some video, but I put this, it's actually a pan liner for a shower from Lowe's, and I put it around the pan because if I use the flood coolant, it sprays everywhere. So the other thing, I'm gonna move real slow to show you this. This is a store-bought cover, like $10, $15 cover for a TIG welding lead. And if you look down here, see that? That's the wrapping that goes around the cable run. See if I can get another look at it for you. See it back there? It's essentially a 3-inch piece of hydraulic hose guard, like a sleeve, it's tube. Cut the 3-inch one lengthwise and cut the TIG welding hose protector lengthwise and sewed them together to make like a 4-inch or 3.5 to 4-inch tube that I could zip together. And that's what I covered that with. Few other modifications that I did, well, like I did the risers and I did that. I threw away all of this and got new stuff from McMaster-Carr because the stuff that came with it was just lousy. Then I moved the tack into the side of the lathe so it's much cleaner. And I put a little see, it's a little hour meter. It's been on for 7 hours. I've been, using a little bit. I kind of got it done. I had to use it. So there it is. I've put the drip pan. I covered all the hoses. I've got it set up here. You can see, I'll zero it out. Right? So cross slide. So I got the DR all hooked up. Let's see. What's it look like? $86. Should be $60. $447. And of course, everything works. Let's see. Trying to do this one-handed is tough. See, it's feeding in. There's a cross slide. Goes the other way. So yeah. There it is. Thanks for watching. See what I come up with next. I think I'll get back on that drumstick splitter project thing. Who knows what the future brings.